Hello and welcome to another Great Cow BASIC tutorial. This is part 14 for the PIC18FxxQ41 chip family. So what are we covering today? We're going to be covering SPI, and I'm going to be using a graphic LCD or GLCD to prove that SPI is pretty simple to use. So what am I using here? I'm using a microchip low pin count demo board. It's the green one. I'm waiting for a red one to come, but I'm using this green one, and the Q41 chip fits in absolutely perfectly. The layout I put here again every day is so that you can replicate it. You can make exactly the same board, and I'm going to be using it to show you how I connect in the SPI. Two things I'm not going to connect in and show you today in any depth is the ground and VCC. They are very specific to your device, SPI device. Make sure they're connected up adequately and you've got the right VCC. So let's talk about what SPI is. SPI is serial peripheral interface. It's an interface bus between components that's to send data backwards and forwards. It's bidirectional, so you might have an input and output, but it connects a microcontroller to small peripherals like a graphical LCD, SD cards, or other small devices. It uses separate clock and data lines, and you'll have other lines like a select line to choose which device you're going to talk to. And so in the diagram here on the top right, I will turn my pen on. You can see I've got a controller, which is my microcontroller, and my SPI device. And that my SPI device is actually the device I'm talking to. And this one is a GLCD. So I've got GLCD device here and my microcontroller. A series of names like SCK, which is the clock, SDO, which is data, serial data out, and you might have other ones like SDI or chip select. Now I put down here names. They have different meanings because we're going through a transition of naming where things used to be called MOSI and MISO, they're now called SDO and SDI. Where it used to be called slave select, it's now called chip select. Now the thing in this is microchip use the legacy or deprecated names, and I'm going to be using some of the new ones. So when you see a data sheet for a product, you're going to have to translate between these things. Basically, you've got data out, chip select, and a clock, and the others you might need for your specific device. So let's have a look at what we've got here. I've got a device, it's a small device. Let me see if I've got one running here. Is it running? There we go, it's actually on the screen there. And you can see in PowerPoint that I've got it connected up through 5 connections. One connection, 2, that's that brown one, yellow, black, and purple. And they connect to the device here at the top. And it's marked ground and VDD, I'm not mentioning those. SCK is the clock, and it's connected to my yellow wire. And now I've connected it into port B7, which is the bottom right pin. SDA, which is the data connection. Serial data connection, SDA, or data out, is connected to the top right. That's one in there, the blue one. And then I've got other lines connected. The reset line, that's required. The DC, which stands for data coming into the GLCD device, or a command coming in. You just need to set it, and the library sets it high or low for you. And chip select. Chip select is selectable so that you can put more than one device on. It works very well. And so in all our programs, we set some defines, and those defines will set us up to make it all work. And they are data out, a clock line, SCK, a DC line, a chip line, and a reset line. And you can see those 5 on the left there. And that's what we're going to connect up. So let's have a look at some sample code, and then we'll see how it actually works out in the lab. Okay. So if actually we look at the lab first, we can see that this is the actual connections. You can see the connections across the top here. And in the code, you'll see that I've got them connected. That says VCC, SEK. Look at that. That says SCL, which is serial clock line, SDA, reset, DC, and chip select, and they're connected in the connections, and you can see them down here at the bottom. Okay, now let's look at the code, and that code will help us understand what's going on. So we have our standard chip, and it's 16FxxQ41 I have attached, and option explicit, which tells it to you have to define your variables. We already know that this is a PPS chip. We know that, therefore we have to set up PPS, or do we? Our libraries come with a software SPI and a hardware SPI, so you can choose which one to use. This one is currently using hardware SPI. If I put a comment in it, all I have to do is uncomment now. I'm going to reprogram it very quickly, and we'll just discuss this option. You can see this on the display there, on the video. The display is working quite quickly. It works quite nicely, and to be honest, visually you'll see very, very little difference between the operation of a software SPI at the higher frequencies. At the lower frequencies, you will see a noticeable difference. So if you set up, we'll use software SPI because we've seen, now we're going to use hardware. So I'm going to go into PPSTool and set it up. So I've already spoken about this. I need to select a few things, and we have to set up the clock line, and we have to set up the SDO. So if I take the clock line SCK, I'm going to put that on B7. Why explain I put on B7, and the SDO I'm going to put on B5. And I add those two in, and as you can see, it's added it into the PPS tool. If I'd only been showing it to you, here it is, added in PPSTool. I've selected them both, and they're both added, and I can copy those into my program. Once they're copied into my program, I can then use them, and that's what I've done here. I've got them copied into my program here. Okay, so how do I tell it I'm using a GLCD? Same as the previous tutorial, I use the hash include less than a bracket, glcd.h, and a greater than bracket. And then I tell it the type, and this is a SDD 1331. And it's the syntax I use. I tell it the GLCD type with a define, and then say GLCD type underscore SSD 1331. And that is all I have to do. Yesterday we used a different one. I think it was a 1306. They're all similar syntax, and they're documented in our help. Then I define my 5 constants I require for the data out, the clock line, the data and command line, the chip select, and the reset, and that's all you do. The setting of the direction and the setting of the operations of those is all done in the library. And as before, we're going to use the software library just to make things nice and easy. You can use the hardware library. It's up to you. It doesn't really matter. So now we're into the real code. And if I just put an end statement there, we can see what it's doing. So if I just compile that up, put it in, we'll see what happens. It just compiles up the program, loads it in through the PIC programmer. Great. We've got some text out on the screen up. And I've stopped it there on purpose because I'm not going to be going any further today. There's no point because you can see the rest. You've used the rest in previous. You've used other commands. But there are specific commands. We can set the contrast. We can set strings. But I've used today GLCD print, but the same as yesterday. Everything starts with GLCD, and you've got a rotate command. So if I want to rotate this around, I can rotate this. So it's a software rotate, or it could be a hardware rotate. I don't know. We'll just come into here, and we'll rotate that around and say rotate rev, which is reverse. What it will do, it will program it and flip the display around. And you can do that at 90 degrees, 270 degrees, and we're actually reversing it 180 degrees. Great. It's upside down. Okay. So it means you can reverse things. And that is the simplicity. Let's recap what we've done. We've used PPS because it's a PPS chip. We set up the GLCD, and this happens to be an SPI or SPI device. And then we set up these ports. And Great Cow BASIC then has an SPI library where you can send those commands. And those commands are embedded in our library. But if I type in HWSPI, SPI transfer, here it is. This is the raw low-level call to send it some data. I can say SPI transfer the value of 55, and it will send out the value 55 on the SPI line. Why? Because I've actually set them up in, first of all, the PPS, secondly, in my constants, thirdly, I actually use the raw command. So we can use SPI. It's a high performance serial bus. The rest of this is not that important. You can use a demonstration on your own, but it's just to show the simplicity of using a GLCD SPI device. And it's the same for RAM, same for other devices in the library that use SPI. So that's about all I wanted to show. Let's go back to PowerPoint. So you've seen me use lines, circles, and text. You can see them on the screen. You saw them on when I was running the demonstration earlier on. It's all relatively simple. The lines are standard commands that you can develop your own solution to whatever you desire. Okay, it's a very broad subject. So what we've seen is sample code there and SPI. Now what we're doing tomorrow, next one, we're going to be using pulse width modulation to dim the LEDs. We've seen that before in terms of using the CCP PMW. Now we're going to be using the other PMW modules within this chip. And then we've got a couple more after that. It's all about using the memory, how to use ProgMem, and then we're going to be looking at Great Cow BASIC and peeling that back. So, do enjoy.